everyone for the fourth day of our session. First, I would like to welcome Miss Sarika ji. A brief introduction about her, if I say then, she is a head of the business development for waste management vertical in green fuels for the pan India plants of the Dalmia Cement. Also, she is holding a designation of Assistant General Manager at the Dalmia Cement Bharat Limited plant. Also, she is looking after the EPR compliance for all DCBL plants as a brand owner, as well as a plastic waste processor. So she is also working on channelizing the different kinds of waste streams to co-processing in the cement kilns for sustainable waste management and thermal substitution through greener alternatives. So, if I'm talking about her past experience, she is holding a 14 years of experience and worked with a geocycle for ACC and Ambuja cement plants in a vertical of waste management. She also has successfully driven various sustainability initiatives for thermal substitutions in cement kilns, MSW management, and plastic neutrality and alternative fuels and the raw materials like that. So let's have a knowledge sharing session with Sarika ji. So hand over into you and warm welcome from our side.
Thank you so much, Khevna. Thank you for the introduction. Thank you, Priyank sir, for bringing together for this platform. Namaskar, all of you. So, first of all, I would like to congratulate each one of you for taking this step towards learning, and this itself shows the enthusiasm and keenness. सूर्योदय अभी वी आर एट द टाइम ऑफ सूर्यास्त बट जो सूर्योदय आपने ज्वाइन किया है सो आई वुड लाइक टू congratulate all of you on that. So talking about can we start the session or are we waiting for more participants? So we can just have a quick round of introduction. All of you we are short of time, so we will just make it very quick. You can tell your name and where you are working or studying, whatever it is. So just a quick round of introduction. We can just
Shivna,
start.
please coordinate. You just speak the name so that everyone can.
Good evening, ma'am. I'm Sanjay. I'm working at SIA office, Telangana, and working as a support engineer. And in addition to that, I'm also providing EIA expertise here. And it's been 5 years, ma'am. That's about it. Thank you.
Thank you. Miss Ahinsha.
Hello, ma'am. My name is Dr. Ahimsa Pandey, and presently I'm not working, but I did MSc and my doctorate in environmental engineering, and I have teaching experience 5 years of, but presently I'm not working anywhere. But just for gaining my knowledge, that's why I joined this session.
Okay. Mr. Anshu. Okay. Mr. Ashutosh. Mr. Chaitresh. Mr. Jeet. Okay. Mr. Kishan.
Good evening, ma'am. My name is Kisan. I'm working at Geodesign and Research as a chemical engineer.
Next is Miss Litu. Miss Litu is there. Okay. Miss Mohammed Wakas. Mr. Nagraj.
Yeah, good evening, ma'am. I'm Nagraj. I had completed MBA in environmental management. Currently working in L&T as a HSC engineer. in Saudi Arabia. Overall, I have 5 years of experience in India and overseas.
Okay. Mr. Saud Ahmed.
Hello, good evening, ma'am. My name is Saud Ahmed. I have completed postgraduate diploma in advanced diploma in industrial safety from Nagpur and enrolled in the course to gain knowledge and to know about the industry. Thank you.
Miss Seema.
Yeah, sorry, ma'am, I have a very bad throat. I am Dr. Seema. I am working as technical manager environment with geodesign.
Okay, thank you. Mr. Siddesh.
Yes. Hi, ma'am. Good evening. This Bhatia this side. I have 9+ years of experience in facility administration domain and currently working with Clear Corporation and administration. I'm very new to this field, EHS sector, and looking forward to grow.
All right. Uh, Ma'am, I think all are done.
Yeah,
Whoever
thank
is
you so
not
much.
speak,
Yeah, no, sure.
yeah, we'll tell them to put their details in the chat
Sure, sure.
box.
So thank you. It was nice to know you all, and we have a diverse group, so it will be good to learn from each other. Please feel free to add value to the content that we are going to discuss. So I will just present my screen.
We have not introduced Kevna, our team.
Yes. I would like to talk about our people also. Like, I request Apurva to start with.
Hi, good evening, David. Sarika ji. Welcome to the session. So, I'm working with EHS services also. Already, we are in contact with you. Working with EHS services regarding the plastic waste management. We are
Yes,
complying with clean energy.
yes.
Yeah. Rashmi.
Hello, ma'am. Nice to meet you again after that conference. So, I am working with EHS also, and I'm doing my PhD in plastic waste management with urban local bodies. So, nice to meet you. Nice to see you after long. Welcome.
Yes.
Ankit sir.
Hello, good evening, ma'am. I am Ankit. I am working also EHS services in different project, and I have completed BSc in ISBM University.
Sarika, he's the person, Ankit. I don't know why you don't switch on your cameras so that at least she can see to each other. Ankit is just a bachelor and pursuing the further higher education in the safety, industrial safety. But he did compilation of all the regulations together, including EPA having amendment of almost 60 numbers,
Mm-hmm.
and plastic waste, e-waste, battery waste, solid waste. So I will share you once all the compilations together with that same color coding in the plastic waste we did.
Oh, okay. That's a big task to accomplish.
Right. And who's else from our side?
Adishri.
Adishri is where? I could not see. Yes,
Yes.
Adishri.
Hello, ma'am. Good evening, ma'am.
She is one of the newest team member in our team.
Ma'am, am I audible?
Yes.
Ma'am, my name is Adishri Mishra. I have done my master's from FRI College and recently I am working with EHS. Nice to meet you, ma'am.
Same here.
Yeah. I guess Mr. Deepak has joined. Mr. Deepak, are you there? Uh,
Yes. So thank you for all the introductions. Very nice to meet you all. So we can start the session. I'm just presenting my screen. I don't have the rights, Kevna, to present. Would you like to present or you can give me the sharing rights?
एक second, I'll just
Is my screen visible?
You can share now.
Is it visible?
Not yet.
Okay. Is it visible now?
Yes, it's visible now. It's coming up. Yeah.
Yeah. So we will talk about co-processing as a technology for sustainable waste management, the concepts, the benefits of co-processing, and why an industry would want to co-process their waste, and why cement as an industry would want
Sarika,
to co-process.
can you remove this one slogan is coming? Just put on the hide
Right.
button.
Ha.
Thanks.
Yeah, so just to set the context, we as a country, when we India is already committed to become net zero by 2070, and considering the major industrial segment, as an industry is one of the major contributors to the greenhouse gas emissions after steel. It becomes very pertinent for cement industry to think of ways in which their carbon footprint can be reduced. It is the need of the hour. So there has to be an approach to adopt all that it takes so that the cement as an industry can become greener. So this is one of the thoughts with which how the sustainability roadmap or the ESG roadmap of cement industry is defined, and using the waste materials as an alternative fuel in the manufacturing process of cement becomes a very important lever to achieve that reduction in the carbon footprint. Now, the second thought on this is every manufacturing process, any industry that you think about, pharmaceutical, automobile, chemical, manufacturing, FMCG, any manufacturing process will generate some kind of waste. While they make any product, there is always a waste that is generated. So, all industries are generating hazardous, non hazardous, various kinds of wastes. And there are the kind of regulation that we have in the area of waste management. You must all of you must be aware of the hazardous waste management rules, the plastic waste management rules, the municipal solid waste management rules. So we as a country, we are governed by a set of regulation and mandates to responsibly handle the waste. So each industry has a mandate, a legal commitment to responsibly handle the waste. So they are looking for the most sustainable way of disposing their waste, whatever is generated in the process. So these are two uh, sides of the industry which can be which finds its common place, and this is how we are talking about co-processing as a concept. So now a little bit about Dalmia Cement. Dalmia Cement is the fourth largest cement manufacturing group in the country, and this is about our pan India presence. So we are present in 9 states with 14 locations, and all these green dots that you can see on the screen, these are the integrated plants. When I say integrated, it means all these plants have an infrastructure for waste management, waste handling. Now, when we handle waste in the cement kilns, we call it co-processing. So it is different. We don't say co-incineration. We don't say burning. We call it co-processing. So what is co-processing? It is the use of waste, any waste material, as an alternative fuel in any energy intensive process. So cement, steel, any manufacturing process where there is a fuel which is being burnt to give energy, all those processes can use waste material as an alternative fuel. So this is called co-processing. And why co-processing is helpful, that we will see it in the further slides. Now I would just like to take a moment to establish why co-processing in the cement kilns is an ideal situation for waste management. So when we talk about any kind of waste, there could be various approaches that can be done to manage that waste. One is we can landfill the waste. Second is we can incinerate the waste. Third, there are many new technologies, waste to oil, waste to energy. So there are different approaches, and one of the approaches is management of waste in the cement kiln. So what happens? Cement kilns actually act like a natural incinerator. Cement itself is a very conducive environment where wastes can be processed. How? Because cement is a long rotary kiln, we all know that, and there is a temperature which ranges from 800 degrees to up to 2000 degrees. So, at this high temperature, everything gets completely combusted. Secondly, there is a high oxygen rich environment present in the kiln. So, this is a diagram of the kiln, and as you know, the limestone is the major raw material for the cement. It's a major raw material for making cement. And limestone is present in this cement kiln. So there is an alkaline environment present which helps in processing of the waste, because in any way we need to add alkaline scrubbing when we are managing the waste, because to absorb the acidic gases. So alkaline environment is already present in the cement kiln. Then the waste gets a long residence time. It will be from here to here. It gets a long residence time of 5-6 seconds, which all helps in complete combustion. And when the waste is combusted at this high temperature, there is no SOx NOx emissions. And when the waste is burnt, all the organic component of the waste will go off with the emissions, and all the inorganic component of the waste will become part of the clinker matrix. So the product which comes out of the kiln is clinker, and the clinker is then again grinded and mixed with a lot of additives, and cement is made, right? So there is no residue left when the waste is combusted. There is no ash left, there is nothing left. Whatever is there, so whatever is ash is there, it becomes part of the cement. You can understand, it will get integrated in the cement itself. So there is no residue left when we are adopting this way of waste disposal. So this is a classic diagram of waste management hierarchy. As we can see, reduce and reuse of the waste is the primary approach that we should definitely take. If this is not possible, then co-processing, as you can see, is placed higher in the waste management hierarchy than incineration or landfilling. So environmentally, co-processing is a better approach for handling waste than landfilling or incinerating it. Now we would just see a comparison of incineration and co-processing. So this is incineration happening. There is a waste, and we will burn fuel in the incinerator, and we will burn the waste. There will be emissions associated with that. And while we incinerate any waste, there is always, we are left with an incineration ash. This ash again needs to be landfilled, which will require land and which will also be a liability to whoever is the waste generator. So this is a classic incineration process. Now let us look at the cement manufacturing process. A cement plant will definitely consume a lot of fuel to make cement as a product, and there will be some greenhouse gas emissions, a lot of greenhouse gas emissions, which are associated with cement manufacturing process. Now, when we are co-processing the waste in the cement industry, instead of getting it incinerated, we are including this additional emissions. We are escaping, we are reducing this additional emissions. So the cement manufacturing operations, whatever emissions are happening, that are only going to happen. There is no additional emission, because we are substituting some part of the fuel with the wastes. So this becomes a more holistic approach. And while we are putting the waste in the kilns, we are able to recover all the energy. So we are able to recover the energy, we are able to recover the mineral value of the waste, which will again lead to a circularity, which will, so we are able to utilize the waste, which leads to a circular economy model. So this is a comparison. In incineration, the temperature range is low. The waste does not get a long residence time. there is additional requirement of fuel, there is additional requirement of alkaline alkalis to be added in the secondary combustion chamber for the processing to happen, and we are always left with a product after incineration which again needs to be taken care of, which all these things will be better handled in co-processing. uh, till now, if there's any question we can take, please feel free to ask if there is any question till what we have understood till now. So we have just seen, yeah, please.
No question.
No question. Okay, so we have just seen that why a cement kiln becomes.
Rashmi has some question.
Yes,
Kevna,
Rashmi.
please coordinate, please.
Ma'am, I just wanted to ask, how does it, when we talk about waste, I was just had a thing in mind. In case, what do you speak up, matlab, what do you have an opinion about calorific value of the waste in case it is a mixed waste? How do you, it can't be a mixed waste, right? So,
Yes.
yeah.
Yes. So there are certain requirements, certain chemical parameters of the waste that needs to be considered while we are putting waste in the cement kiln. I will talk about it.
All
I
right.
will
Okay.
in the
Yeah.
further slides. So it's not that everything and anything can be just put in the cement kiln. It's not that. So there is a huge process before the waste is brought in a state in which it can be fed in the cement kiln.
All right.
So it has to be because when we think of waste will be in all kinds of physical states. Waste will be solid, liquid, sludges, semi-solids.
Mhm.
Physical parameters will vary. Then chemical parameters will vary. It's not a product कि हम उसको quality उसका set कर सकते हैं. It's a waste. It
Mhm.
can have any chemical constituents. It can have heavy metal. It can have anything. So chemical nature will vary. But while we are considering it for co-processing, there is a prerequisite in terms of the chemical parameters that will not disturb the process, because you have seen that this waste management is happening along with the cement manufacturing. So there has to be cement, for a cement industry, cement manufacturing is the core business, and there can be no compromise on the cement quality. So how it is done, every waste is first analyzed in the laboratory. Whenever we are starting with taking a new waste, suppose from an industry, a manufacturing industry, they generate some waste, we will take a sample, we will analyze that waste, and we will come to know what are the chemical parameters. So the entire proximate and ultimate analysis is carried out in the laboratory, and we know the parameters. And this is how we know the parameters of all various waste streams which are landing up in the cement plant. And then a right mix is made, which will have a certain specification in terms of four major parameters, which is calorific value, ash, moisture, and chlorine. These are the critical parameters. Other than that, we also have to maintain that it should not have heavy metals. There is a banned list that the cement plants will not take, which contains radioactive waste, anatomical waste, hospital waste, waste containing very high heavy metals. So these are the waste the plants cannot handle because it will have an impact on the cement quality. So this is how the waste properties are monitored, tracked, and then a suitable mix is made. So this is the we call it pre-processing. So there's a team in place which will make the right mix. Suppose we have 10 streams, uh, 5% of this, 50% of this, 10% of this, and a waste mix is made, which will meet the specific requirements.
Okay. Thank you so much, ma'am.
So when I say that there are four major parameters, so the calorific value, which is ideal, should be more than 2000 calorie per gram.
Okay.
The moisture should be not more than 40%, because if we increase the moisture, there is a lot of coal requirement that will increase. So the waste should not have very high ash. Very high means more than 50-60% ash should not be there. And chlorine is a critical factor, because chlorine, if there is a limit to chlorine. If it it exceeds, then the chlorine will remain in the kiln. So it will disturb the entire process. So we are also very specific about the chlorine input. So now,
What was the moisture level, Sarika?
sir, moisture we usually restrict to 50%, but it's not that we can't do it. We can even do higher 70,
It's okay.
80%.
And ash is also 50 to 60%.
Yes, sir, 50% maximum.
And
And there
chlorine
is a
level?
chlorine in the incoming waste, sir. What we are feeding, not more than 3%.
So, as a general user or waste generator,
Hmm.
where a EHS person is working,
Hmm.
any tips to all of them how they identify their waste, which may or may not be suitable for the cement kilns?
Yes, so
Because rest process is with you. Certainly, you will do the examination, you will take the sample,
hmm.
you will analyze, and then get back to the customer. But in a first look, what key parameters a EHS person or a respective industry person should analyze, so that
Hmm.
he can have an idea कि yes, ये मेरा वेस्ट सीमेंट क्लीन के लिए शायद जा सकता है इंस्टेड ऑफ इंसिनेशन.
Yes, yes, sir. So, first of all, like this waste handling comes under the EHS function for all the manufacturing processes. So, uh, overall, mostly all kinds of waste that are generated can be utilized by cement plants. But how we take a decision on that? So, one thing is, if when I say waste, any kind of sludges, ETP sludge, paint sludge, all kinds of waste, what we have to check if we have to think whether my waste can be utilized by cement plant or not, if your waste does not have heavy metals, and if the waste does not have very high chlorine limit. These are the only two critical parameters that you need to understand. Very high chlorine means more than 10% of chlorine in the waste if it is not present, and if the heavy metals are not present more than 5%, this waste can be processed in the cement. Now, even if your waste has 80% moisture, there is a way to do it. So what we will do at our facility, we will impregnate. So we will use some agro based wastes, which could be rice husk, mustard husk, any agro waste, and these wastes are mixed with your waste, so that it becomes flowable. It has to be transported on a conveyor belt till the kiln inlet or the preheater top where it has to be fed. So it has to get that consistency. So those things are possible. So you have to get in touch with the cement plant to check. Once the cement plant analyzes the waste, they will figure out a working plan of what needs to be done to your waste so that it can be co-processed. And why a company should look for co-processing as an alternative? Because we've seen its co-processing benefits in comparison to incineration or landfilling, but also co-processing gives any company which has opted for it, it gives a greener image. It enhances your ESG roadmap, because if you are getting your waste co-processed instead of landfilling it, a lot of companies these days, they are committing to a zero to landfill model. So co-processing gives you that edge, that enhancement in your sustainability reporting also. So this is one advantage that co-processing, why co-processing has to be preferred. We also process liquid waste, so waste from the pharmaceutical industries, like spent solvents, the beverage industries, all this expired beverage that we have, all these are taken in the cement plants and co-processed. So, and also another segment which I would like to share is uh, municipal solid waste, which is the biggest chunk of waste. What we will think every single day, every household is generating waste, marketplace. So all this municipal waste also, when it is segregated, the combustible fraction of the municipal solid waste is also co-processed in the cement kilns. So all the non-recyclables plastics, all the from the municipal waste, the paper, cardboard, footwear, cloth, all these kinds of wastes are segregated and they all go to cement plants for co-processing. because cement also in capacity, there is uh, in our country we have cement plants in all geographies, and there are so many cement plants. So it becomes a very beneficial scenario overall. If the right waste can be channelized to the cement plants, we can end up in solving a lot of waste associated problems. So it definitely has a good positive impact on the environment, because it helps us reducing our carbon footprint, and it helps us reducing our usage of conventional fuel and substituting. So whatever part we're able to substitute, instead of coal, if we are able to use waste, it is saving on the natural resources, which is a key. And if we so why a company should go for it, if we look at it from a larger perspective, it will also lead to a reduction in the carbon cess that the country is incurring right now when we are importing the conventional fuels. So this all will play a big role if this is adopted on a larger scale. And co-processing is a method, as a methodology. It is certified and authorized by Central Pollution Control Board and Ministry of Environment, Forest and Climate Change. So it will also help an industry to achieve their legal and statutory compliances in the right way. Now, I would just share in brief on what are the major steps that are taken for safe handling of the waste. There is a huge infrastructure required at the plant level when the wastes have to be co-processed. So once this is just a process which is followed at any cement plant which handles waste. So there has to be a sound unloading system, because it is all the movement is happening by trucks. The trucks are coming, and there is a separate co-processing units which are made integrate in the integrated cement plant. So there's a separate area for waste management, and the unloading happens. Then each single truck that comes in the cement factory, we there is a representative sampling done. A sample is taken, and the sample is checked in the laboratory for the key parameters. The four parameters I said, those are checked. If they are within the permissible limits and acceptance criteria, then the vehicle is unloaded, and there is a storage system. Any typical cement plant will have a storage of at least 3,000 to 6,000 to store this much quantity of waste. And there are certain norms which are prescribed by the State Pollution Control Board and the Central Pollution Control Board with respect to the firefighting. It has to have a concrete flooring where the waste is stored, and there has to be an odor control system, because we deal with a lot of municipal waste which can have a lot of smell issue, and the plants are located within the communities. So there are certain guidelines which have to be followed, which are in place at the facilities. And then if you have ever seen any waste management facility, the material recovery facilities in the cities, all cities, they have a mandate to have the material recovery facilities for the municipal solid waste. It is a similar kind of facility you would see in a cement plant as well. There are trommels, there are shredders, there are ballistic separators, magnetic separators, and the waste has to go through all these processes. So because in the kiln we can't feed material which is more than 50 size, so everything has to go through a shredder where the size reduction happens. And then there is a feeding system of conveying system through conveyor belts. Waste is then fed in the system. And talking about the compliances, the environmental compliances in the cement plant has continuous emission monitoring system, and to check there is no SOx NOx emissions, and the emissions are within the permissible limits. So this is a classic flow chart of what we do in the cement plants. Now I would just share about, I have talked about the reduction in the fuel that happens when we are processing waste in the cement plant. So if you see this, these are some of the numbers. We started co-processing this waste in Dalmia Cement has started in around 2018, and from a thermal substitution rate of 6%, today we stand on a group level at about 24%. And there are plants which are able to achieve a thermal substitution of about 40% as well. So when we try to increase the waste consumption in a cement kiln, what happens, the plastic waste, a lot of it is plastics that we co-process, and the chlorine input gets increased. So there are chlorine bypass systems which are installed, and these chlorine bypass system helps us to bypass the chlorine, and this would help a cement plant to increase the quantity of waste that they can process. So Dalmia Cement is the first cement plant in the country which has installed chlorine bypass systems, which has enabled us to increase the quantum of waste that we have processed in the past years, and helped us achieve a thermal substitution of about 24%. And we aspire to achieve about 35% thermal substitution by 2030. So I would just share about some of the initiatives that we have taken as part of our sustainability journey. We have deployed the EV trucks, so our entire fleet for raw material movement is through EV now. We are also one of the largest consumers of slag, the waste which comes out from the steel industry. Slag can be mixed and utilized while manufacturing cement. It also becomes part of the cement, and we make those types of cement which can use a lot of slag. So we are the largest consumer of slag. We also consume a lot of fly ash in making the cement. We are also the pioneers for doing the transportation of fly ash through rake. So because when we do any transportation through rake, it has a lot of environmental benefits. In addition to the savings in the logistics cost, there is a huge impact on the, and so the quantum that we would transport by trucks, and we would do this transportation in one rake, can have a lot of impact. So we are the first company to do fly ash transportation through rake, and we have also done one pilot for transporting RDF, the refuse derived fuel, the segregated municipal solid waste, also in a rake from West Bengal to our plant in Odisha. So these are some of the initiatives that the company is taking in order to reduce the carbon footprint by the emissions that are caused due to the vehicular movement. And we have set up state of the art facilities at plants for sustainably and safely processing all kinds of waste. So if any of you is interested to visit some of the cement plants and see what actually happens to the waste, how it is processed, please get in touch with me, and we can organize a visit, and it will be interesting for you to actually see and understand how the process is done. So I'm also proud to share that Dalmia Cement also has the lowest carbon footprint globally. So on an average, the entire Indian cement industry is much lower on their carbon footprint considering the global average. But here also, we are also the least. When I say carbon footprint, it means the kgs of carbon dioxide emitted for per ton clinker production. This is how we map that. So we are currently at 459 kgs per ton of clinker production, which is least as of now. So these are some of the initiatives which the company is taking up as part of our sustainability journey. And because we want to become more responsive in our operations, aspiring to be a greener cement company, these are the initiatives that are important. And usage of waste is one of the key factor that can help us achieve this aspiration. So this is all about the process and the details. This is just the with a lot of experience establishing the state of the art facilities and expertise in the operations, we would want to deliver on our credibility, capability, and commitment to the entire clientele that we serve. So I would welcome all the questions on what we have discussed.
So if someone wants to dispose any waste to the cement kiln or to the Dalmia cement, what would be the process? How they can approach to you? Uh, and
Yes.
are you supporting to the industries to get it done their plastic waste credit support as well?
So I will just talk about that. So all of you working in different industrial segments, and waste will be generated mostly in all the cases, any manufacturing operation. So you can definitely consider co-processing as a methodology, as an approach that you would want to take for your waste. It would help you achieve zero waste to landfill, and will also accelerate your ESG. So you can get in touch with us, and while we process the waste from across the country, we will always look for the nearest cement plant approach. We ourselves are present in 9 states, catering to those 9 states plus the neighboring states, and we would want to map your site with our nearest cement plant so that we are logistically effective, and we would definitely like to understand if we can process your waste. That engagement can happen and service can be given. Now that we just to give you a perspective, last financial year we processed about 16 lakh tons of waste across our plants pan India. So out of this 16 lakh tons, there was about uh, 12 lakh tons of segregated combustible fraction, the RDF, that we have processed, which contain a good quantum of plastic waste as well. So, just taking a moment, just taking 2 minutes on the EPR, Extended Producer's Responsibility for Plastic Packaging. The various approaches that are specified in the EPR rules: recycling, use of recycled content, and there is reuse, and there is one end of life disposal. So co-processing as a technology, it comes under waste to energy. End of life disposal as an approach for handling plastic waste talks about waste to energy. So co-processing as a technology comes under waste to energy, and this is how, by doing this process, we can generate end of life credits for plastic packaging waste. So the waste that comes to us, the municipal solid waste, segregated plastics, non recyclable plastics, come to our facility, and that contains primarily category 3, the multi-layer plastics, and some part of even category 2, and a very small part of category 1. So we also generate end of life credits for category 1, 2, and 3. So in all your respective functions, if you are looking for a partner to who can help you for your EPR compliance, cement plant can also support you on that. We can also engage on the EPR, and we will take care of the EPR compliance requirements that the industry has. So we can have
Okay.
some questions now. I saw someone raised the hand. You can unmute and ask.
Good evening, ma'am. Ma'am, may I ask a question? It's not regarding to the disposal of waste. It's regarding to health and safety of your workers in cement industries. What kind of measures taken there, and any data, routine health checkups, and any pollution control board ask you what about the safety issues and health issues of workers? What initiatives taken by the Dalmias?
Yes. So one thing is that we are all bound by this industry regulation, which under which we are required to do the complete health checkup, health background, and a regular health checkup for all the employees. So all the workers, all the employees. But when I talk about specifically this waste management, there are certain regulations because people are handling waste, so there is an additional requirement, an additional focus which is required for the people who are handling waste, because they are prone to, various concerns, the safety concerns. So there is an SOP in place at plant, and which will include usage of all the required PPEs. And uh, these PPEs are different from the regular PPEs. So when you visit a cement plant, you the PPEs that you would take, maybe the safety shoes or the helmet. But when you visit the waste management site, you will also require to use a canister mask. You will also require to use the safety goggles. So these are the additional layer of requirements that we have mandated for the handling of waste. And also the facilities are equipped with the emergency response procedures, so that in case of any requirement, situation can be handled. So cement plant has a very robust, I mean, at the plant site, this has a robust standard operating procedure in place for health and safety.
Thank you, ma'am.
Because health and
Hello,
safety
ma'am.
becomes more pertinent when we are looking at employees or the workers or the professionals who are working at the waste site. So it is much more than I mean, more focus is required. So there is also a compatibility test that happens. So we also take care of the because I have told you about the storage sheds which are there in our facilities, and various kinds of wastes are kept together. So we also have a sense of wastes compatibility, so that there shouldn't be any chemical reactions happening when the two three kinds of wastes are stored together. And it should not have an there shouldn't be any accident because of that. So that compatibility of the wastes which are stored is also always taken in consideration. And also while transportation of the waste, so it's not that we can transport different kinds of waste in a single vehicle unless we are sure that there will be no compatibility issues of the waste. And also, I mean, from the hazardous waste guidelines, so hazardous waste and other management of hazardous and other waste rules which are there in place, so they give a complete guideline and statutory mandate on how hazardous waste has to be managed, right from the waste generators and during the transit of the waste, during the transboundary movement or within the state movement. It gives the detailed guideline which has to be adhered to: waste generator, transportation, and while the waste is reached to the disposal end, what steps have to be taken. This all is uh, already detailed out in the guidelines clearly. Yeah. Someone else want to
Hi,
comment?
hi, Sarika. Good evening. This side,
Good evening.
Alupa.
Yes.
Can you let me know that is any of the waste generated by the cement plant while processing all the while co-processing of the such type of things and making into the cement? So
Yes.
any of the waste generated from your ends?
So when we process the waste, as I said, so whatever we are putting, all the waste that we're putting inside the kiln, there is no residue. There is nothing that comes out of the plant. So we only get the product. So all that becomes part of the cement. So there is no residue. There is no nothing remain. Nothing remains from the waste. From the waste that we process, we don't have any leftover. And as it is also, the cement plant will not generate any waste except the emissions. That is the major
That's
cause
great.
of concern.
Agree.
So
So
there is
the
no,
what
we
the
don't
measure you
generate
have
waste.
taken for the emissions part? Are you we only putting the retrofitting devices, or we are doing something else that the emission has been going be the downer side, or in the sustainability report or in the ESG pattern, are we have are your plant has been or your organization has been taken that part taking care of that part, like materiality of reducing the emissions?
Yes. So there is a prescribed limit for the cement plants. So in emissions, what all can be there in the emissions, how much emissions. So we have to ensure that while we are operating, our emissions are as per the limits which are set for the cement plant, which is specific to cement manufacturing operation. And we have a continuous monitoring system which SPCB also has an access to verify. So this is the process in place. And other than that, the other initiatives that we have taken to reduce the emissions, like I said, alternative fuel usage is one of the initiative that is there. And I mean, if you talk overall about what we are doing regarding our carbon footprint, there are a lot of initiatives for carbon sequestration that we are investing in, so that our carbon for the carbon management. So these are the some of the initiatives.
Okay, thank you very much, Sarika. Thank you.
So also, I mean, as per the regulatory norms, when we go for this also has a linkage to the reduction in scope 1 and scope 2 emissions through co-processing of the waste.
So again, one question: there is scope one and scope two for the organization, or we are talking about the SBTI target for the same?
Yeah, for the waste generator, for the industry which generates waste.
Okay, so we are saying that this is the organization is scope one and scope two,
Hmm.
not
Yes,
a
yes,
not a product.
yes, yes,
Okay, thank you.
Ma'am.
yes. So I'm just present this slide has my contact details in case of even further. If you have any query, any anything to be discussed, I would welcome you to please reach out to
Yeah,
me. So
Sarika ji,
I'm
I
just
think, sorry to interrupt you. I think from starting, Nagraj want to ask something to you. Nagraj
yeah,
ji,
yeah,
if you
please,
have any query, you can ask.
yeah, please ask.
Thank you, ma'am. Ma'am, co-processing will be the one of the carbon reduction mechanism.
Mhm.
Through the carbon offset mechanism, can I get the carbon credit certificates?
Yes, of course. So carbon credits as a market, it is not yet a mandate in our country, and we don't have that market. But very soon, this is going to be a requirement and a mandate and a potential market. So definitely, carbon credits can be claimed through co-processing. So this will generate carbon credits. So right now
Okay,
it's a
ma'am.
voluntary market, even the plastic credits, similar way. So we have EPR mandate, which is for the packaging, but then there is a voluntary plastic credits market also, which a lot of FMCG and big corporates are right now also I mean, they are party to that. So this also is pertinent for the plastic credits and carbon credits. So this once we are able to capitalize on the carbon credits through co-processing of the waste, this entire framework will become all the more economical. We haven't touched on the economics of this model and how this is economically viable or not viable. But yes, when this carbon market will be open, this entire framework will also become a lot more commercially viable.
Okay, Rashmi, you want to ask something, please?
Yeah, Sarika ma'am, I just wanted to ask when you said that MSW, matlab there is a fraction of waste which is tested, like you say that category one comes in a little
Mhm.
amount, and likewise
Mhm.
you get a lot of MLP. So, what do
Mhm.
you have to say about the sanitary waste coming, matlab, seeing the newest which came on 6th December, I think, the draft rule, which is talking about sanitary waste, the sanitary products which are coming in the market. So they have to, be catered in the EPR system. So, I personally, when I read a lot about these researches, so a lot of it goes into incineration. So, what
Yes.
is the basic reason that they are not being processed through, yeah, contacted towards, yeah, channelized towards
End of life.
co-processing? Yeah.
Yes. So as of now, we this is one of the banned category that cement plants cannot handle, more
Okay.
because of the associated health and safety concerns. So
Mhm.
sanitary waste, if it has to be addressed, that has to be a closed loop system, which currently the cement plants right now here do not have that system in place to do it all in the closed loop system. So we are not doing any sanitary waste, so there is no end of life, as you must have seen in the draft as well. There is end of life is not prescribed for the sanitary waste, only recycling, right?
Okay.
So this is one stream that we cannot handle purely because of the safety concerns associated with it.
Okay.
So, but in some of the Western countries, even the hospital waste can be addressed. So there is one is the health and safety concern. Second is a lot to do with the mindset, and
Mhm.
we as a community, what we are currently receptive to. So, for example, because eventually cement is being made, and there is, so while we as an industry started even co-processing waste in the cement plant, there was so much of resistance from the communities, from the NGOs on the so it was like कि अभी कचरा जला के कैसा सीमेंट बनेगा ये सीमेंट. So the acceptance of the customer towards it, so all these are also some of the mental blocks that we have to overcome if we have to reach to the stage. But currently, yes, this is how the scenario is.
Thank you so much.
Sarika, last question for you. As cement industry is having some benchmark nowadays as a green steel. You may be heard recently there is a green steel.
Hmm.
I think it is a 2.2 kg CO2 emission per ton of the production. If steel is generating
If
to
steel has to.
2.2 kg CO2 per ton of the production or less than that shall be accounted as a green steel. So, is any uh, way forward for the cement industries as well? Ki we are going to be get the green cement.
Sir, steel maybe. I mean, although we have these limits, but still, I mean, you know it better than anyone else. अभी green cement हम कैसे green steel हम कैसे कह सकते हैं, या as in concept.
The government fix
हाँ.
some
हाँ,
guidelines over
लेकिन
there.
अभी सर सीमेंट में तो ऐसा कुछ भी
ऐसा
मैंडेट
नहीं है अभी
नहीं
नहीं
है.
है.
सो नॉट
But
टिल.
how much CO2 emission you are generating per ton of the cement?
Sir, 450 kgs per ton of clinker production.
Clinker. Okay.
Per ton of clinker. So 1 ton of clinker will make almost 1.8 tons of cement.
Okay. Okay.
Sim,
So
हाँ,
it will come down, I think,
हाँ, it will
per
come
kg.
down, but yeah, सीमेंट से आप
Right?
करेंगे तो थोड़ा हाफ हो जाएगा, बट क्लिंकर के साथ हम उसको कंप्यूट करते हैं बिकॉज क्लिंकर इज फॉर.
Understood.
हाँ.
Understood. Thanks, Sarika. Kevna, over to you.
Thank you so much. So I am not sure if the participants could be engaged. Because there were not a lot of discussion, and it would always be nice to make it more interactive, more question and answer. But feel free to reach out to me even later if you have any question, if you want to understand anything further, which maybe in 1 hour's time we might not be able to elaborate. I will be very happy to address that.
You can understand the students always reluctant to ask the question.
हाँ, right. So आप बाद में भी पूछ सकते हैं, and it will be a pleasure to interact with all of you.
Right. Thank you, Sarika, for your time, for your patience, and give us a very